Hello friends, today we are going to discuss the topic work from the chapter Work and Energy. Energy is the capacity to do work, or you can say energy is the physical and mental strength that allows you to do things like playing, writing, running, jogging, etc. So as we said, energy is the capacity to do work. So now what is meant by work? Observe the following examples. Well, are all the people mentioned in the examples doing work? There is a difference between the term work, we use it in our life, and the term we use it in science. In our common view, persons mentioned in example 1 to 4 are doing work, whereas according to science, only the persons mentioned in example 1 and 2 are doing work. Let us see why. Because according to scientific concept, work is said to be done only if two conditions are satisfied. That is, force should act on the body and the body should get displaced. Displaced in the sense the body should change its position. Now, in example 1, a person is lifting a cement bag. So when he lifts a cement bag from the floor, he is applying the force. So here condition 1 is satisfied. After lifting the bag, he is placing it into the truck. So here position also changed. It was on the ground and now the bag is in the truck. So displacement is done. So we can say work is done in the first example. Now similarly, if you look into the example 2, a girl pulling a toy car. So she is applying the force and pulling the toy car. The toy car changed its position from A to B. So force is applied and displacement also done. Position of the car is changed. So in this case also work is done. Now if you see example 3, a boy is pushing a rock. Though he spends lot of energy in pushing the rock, force is being applied but there is no change in the position of the rock. So in this case work is not done. In example 4, porter standing in a railway station. He is lifting a luggage on his head. He is applying the force, spends a lot of energy against the gravitational force acting on the luggage. So force is applied but the luggage is still on the head. The position of the luggage is not changed. So displacement is not done. So two conditions are not satisfied. So work is not done in this case also. So now by looking at these examples, it is clear what is work. Work is the product of force and displacement. Force should act on the body and there should be a displacement. Now let us come to the units of work. The SI units of work is, force unit is kg into meter per second square, and this into displacement unit is meter. So kg into meter per second square is also called as Newton. We can write it as Newton into meter. This whole thing together, Newton into meter, is called joule. So work unit in SI system is joule. If you look in CGS units, work is equals to gram into centimeter per second square. This is the unit for force in CGS units, into centimeter. Displacement unit is centimeter. Now gram into centimeter per second square is also called as dyne. So work is equals to dyne into centimeter. Dyne into centimeter together is called as ergs. Now if I ask you to define joule and erg, joule is nothing but amount of work done when the force of 1 Newton displaces the body by 1 meter. Similarly, erg is the amount of work done when the force of 1 dyne displaces the body by 1 centimeter. Now let us see the relation between joule and erg. 1 joule is equals to how many ergs? Joule, just now we have seen kg into meter square by second square is equals to, we have to find out the ergs. So let us convert this. Kg, 1 kg is equals to 1000 grams. So in kg's place I have written 1000 grams. meter. 1 meter is 100 centimeter. So since we have square here, so that's why I wrote 100 square to centimeter square by second square as it is. Now here 1000 grams into 100 square means we get a 40 here, and then centimeter square by second square. In total, if we count these zeros, we will be getting 7 zeros. See, 1, 2, 3, 4, 5, 6, 7. Instead of writing like this, we can simply write like this: 10 to the power of 7 gram centimeter square by second square. Gram into centimeter square by second square is nothing but ergs. So 1 joule is equals to 10 to the power of 7 ergs. This is the relation between joule and ergs. Now, a ball moving on a plain ground, you can see a ball moving on a plain ground gets stopped after some time due to the frictional force acting on the ball. You can see the ball is getting displaced and the force is acting in this direction. So the displacement and force both are in opposite direction. When displacement and force are in opposite direction, then the work done by the force is taken as negative. So this negative signs tell us that force and displacement are in opposite direction. If work has negative value, then the body on which work has been done loses energy. And if the work has positive value, the body on which work has been done gains energy. I hope you all have understood this. Okay, so now let us start with the numericals which are based on work formula. The first question is, what would be the work done when the force on the object is 0? So they are asking us to find out the work done when the force is 0. So we all know the formula of work, that is W is equals to F into S. Force value is given. Let us substitute this value here into displacement. So the result is anything into 0 is 0. So we can say here work done when the force on the object is 0 is nothing but 0. Now let us solve the second one. In this case, they are asking us to find out the work done. Now here the displacement is 0. So now S is 0. Work done we have to find out. The same formula again, W is equals to F into S. F into S value is 0. So anything into 0, 0. So work done is 0. Now let us do the third one. A boy pushes a book kept on the table by applying a force of 4.5 Newton. So here force is 4.5 Newton. There is a book which is pushed by applying a force of 4.5 Newton. Find the work done. So we have to find out the work done by the force if the book is displaced through 30 centimeter along the direction of push. So the displacement is 30 centimeter. So now before solving the problem, we should check that all the units are in either SI, they should be either in SI units or CGS units. Here in this formula you can see force unit is in SI units, but the displacement units they have given in CGS units. So first we have to convert this into SI units. So 30 centimeter we have to convert it into meters. So if we do 30 by 100, 0, 0 cancel, the answer will be 0.3 meters. So the displacement is 0.3 meters. Now by taking the work formula, W is equals to F into S, substitute the values. Force value is 4.5 Newton into displacement is 0.3 meter. If you do this calculation, 4.5 into 0.3, 5 3s are 15, 4 3s are 12, 13 into 0 5s are 0, 0 4s are 0, 5 3 1, 2 place point places, like we have to leave 2 here, 1 2, so point will be here. The answer will be 1.35, and work has a unit, SI unit is joules. So the answer is work done is 1.35 joules. Okay, now let us do the fourth one. Calculate the work done by a student in lifting a 0.5 kg book from the ground and keeping it on a shelf of 1.5 meter height, considering the value of G is 9.8 meter per second square. So first thing you'll have to do is whatever values are given in the problem, first note down that. So here they have given 0.5 kg book. So mass of the book is 0.5 kg. The book is lifted from the ground and we are keeping it on in a shelf 1.5 meter height. So the displacement is 1.5 meter, and the value of G is 9.8 meter per second square. Calculate the work done. So we need to find out the work done by the student. So now work formula we know, W is equals to F into S. So in this three cases we have seen directly they have given the force and displacement values, but here the force value is not given us directly. So what we will do is, we know the force formula, that is mass into acceleration due to gravity, and then this part comes here into displacement. So now let us substitute. W is equals to M into G. M is 0.5 kg, 0.5 into G value is 9.8. So 9.8 into displacement 1.5 meter, 1.5. So when you do the calculation part, let us first solve this one. 0.5 into 9.8, 8 5s are 40, 8 zeros are 0, 4 into 9 5s are 45, and this 9 zeros are 0, and this 4 comes here, 0, 5 plus 4 is 9, then 4, 1 2, then we have to keep point here because after 2 we have a point, so 4 1 2 then point, so 4.9 is the answer. For this mass into acceleration we got 4.9 answer into 1.5, displacement is 1.5, and now if we do 4.9 into 1.5, 5 9s are 45, 5 4s are 20, 20 plus 4 24 into 1 9s are 9, 1 4s are 4, so 5, 9 plus 4 13, 4 5 6 7, so 1 2 7.35, and the units for work is joules. So now this is the work done by a student. Let us do the fifth one. Okay, in fifth one, a box is pushed through a distance of 4 meter. So there is a box which is pushed, distance is 4 meter, that is displacement is 4 meter across a floor offering 100 Newton resistance. So the box which is kept on the floor, when it is pushed, the displacement is 4 meter and the floor is opposing the box, the frictional force acting on the box is 100 Newton. resistance, or you can say the frictional force is 100 Newton. How much work is done by resisting force? So they are asking us to find out the work done. Now as you can see, the displacement and the force are in opposite direction. So we need to take a formula. W is equals to minus F into S. We get a negative sign here because both the directions are opposite. So W is equals to minus 100 in place of force into displacement value we know 4. So 4 into 100, you all know it is minus 400 joules. So this is the answer. So let us solve the sixth numerical, that is a ball of mass 0.5 kg is thrown upwards, reaches a maximum height of 5 meter. Calculate the work done by force of gravity during this vertical displacement, considering the value of g 10 meter per second square. So here mass of the ball which is thrown upward, this is the ball with a mass 0.5 kg is thrown upwards with a displacement 5 meter, or you can say height is 5 meter. Calculate the work done. We need to calculate the work done, and the acceleration due to gravity value they have given, g is equals to 10 meter per second square. So in this case we will take the formula as W is equals to minus F into S. Why minus? Because the displacement and the force of gravity is both are in opposite direction. That is why we have taken this formula. Now if you substitute the values, W is equals to minus F, you know it is mass into acceleration due to gravity into displacement. W is equals to minus mass is 0.5 into 10, and the displacement value they have given 5 meter. W is equals to 0.5 into 10 is 5, because 0.10, so this 0 is removed. Minus 5 into 5, which is nothing but 5 5s are 25, so minus 25 joules. So this is the work done. So by this we end our topic.